December 18th, 1944. 0620 hours. Ordnance Depot, Liège, Belgium. The Sherman tank sat in Bay 7 with its entire transmission spread across the concrete floor like the internal organs of some massive steel creature. Oil pooled beneath the disassembled components, frost forming at the edges where winter cold met warm lubricant. Through the depot's open doors, I could see the snow falling steadily, covering the Belgian countryside in white silence that muffled the distant sound of German artillery. The Battle of the Bulge was 3 days old, and every functioning tank was desperately needed at the front. My name was Eleanor Morrison, and 6 months ago I was teaching high school mathematics in Lincoln, Nebraska. Now I was a civilian technical specialist with the U.S. Army Ordnance Department, and I had exactly 4 hours to rebuild this transmission, reinstall it in a 30-ton tank, test the repair, and get this Sherman back to the front line where American troops were dying because they didn't have enough armor to stop the German offensive. The German tank crews advancing through the Ardennes would have laughed if they'd known their opponents' tanks were being maintained by a woman who'd never seen a transmission before 1944. Their intelligence reports dismissed American maintenance personnel as inadequately trained civilians with no mechanical aptitude. A captured Panzer manual we'd translated included this assessment: American tank maintenance relies on factory-trained specialists who cannot perform field repairs. Their crews lack mechanical knowledge. Their support personnel are often women with no technical background. This maintenance inadequacy ensures American armor will be unreliable in sustained operations. They were about to learn that the mathematics teacher from Nebraska could rebuild a transmission faster than their factory-trained specialists, that American amateur mechanics could keep tanks running in conditions that left German panzers immobilized, and that 750,000 women working in maintenance, repair, and logistics roles were about to demonstrate that systematic organization and proper training mattered more than traditional craftsmanship. The transmission components laid out before me represented 237 individual parts, each one numbered, each one requiring specific placement in precise sequence. 6 months ago, this would have been incomprehensible, a random collection of gears, bearings, shafts, and housings that might as well have been alien technology. But the U.S. Army had developed something the Germans never conceived: a systematic maintenance program that broke complex repairs into simple, teachable steps that anyone with basic mechanical aptitude could master in weeks. "Morrison, you've got company." Sergeant James Wheeler, the depot's military liaison, appeared at my workstation with a young infantry lieutenant whose muddy uniform and exhausted face told me everything about conditions at the front. "This is Lieutenant Patterson, 3rd Armored Division. He needs to know when his tank will be ready." I checked my watch. 0623 hours. "Lieutenant, this Sherman will be ready for pickup at 10:30 hours. Transmission rebuild, final drive inspection, track tension adjustment, full systems test. 4 hours guaranteed." Patterson stared at me like I'd claimed I could make the tank fly. "Ma'am, with respect, the maintenance battalion told me this repair would take 2 days. The transmission is completely disassembled." The maintenance battalion uses traditional methods. We use systematic procedures developed specifically for rapid field repair. This transmission will be rebuilt according to technical manual specifications, tested to full operational standards, and ready for combat operations by 10:30 hours. She's not exaggerating. Morrison holds the depot record. Rebuilt a transmission in 3 hours, 17 minutes last week. She'll have your tank ready on time. The lieutenant's expression shifted from skepticism to something approaching hope. "My company is down to 4 functioning tanks. We're supposed to be holding the northern shoulder against an entire Panzer division. Every tank matters." "Then this one will be ready when you need it, Lieutenant. I promise." As Patterson left to get some hot food and maybe 30 minutes of sleep, I turned back to the disassembled transmission and began the systematic process I'd performed 43 times in the past 6 months. Each component had a number. Each number corresponded to a specific location in the assembly sequence. Each step had been broken down into simple operations that required no prior mechanical experience, just the ability to follow instructions precisely and verify each step before proceeding to the next. The Germans would have called this approach simplistic, beneath the dignity of proper mechanics. They trained master craftsmen who understood transmissions holistically, who could diagnose problems intuitively, who relied on years of experience and technical expertise. Their approach produced excellent individual mechanics who could perform repairs in days that required deep understanding and careful craftsmanship. Our approach produced adequate mechanics who could perform the same repairs in hours by following systematic procedures that eliminated the need for deep understanding. We'd turned transmission repair from an art to a science, from a skill requiring years of training into a process requiring weeks of instruction. And we were keeping more tanks running than the Germans could imagine possible. The journey from Nebraska mathematics teacher to Belgian tank mechanic had begun 9 months earlier, in March 1944, when I saw a recruiting poster at the Lincoln Post Office. Women needed for technical positions, Army Ordnance Department, mechanical aptitude required, no experience necessary. The notion of women performing mechanical work on military equipment would have been absurd in 1940. Women didn't work on cars, didn't understand machinery, certainly couldn't maintain combat vehicles. That was men's work, requiring physical strength, mechanical knowledge, and technical expertise that women supposedly lacked. By 1944, the mathematics had changed. The U.S. Army had deployed millions of men overseas, creating massive labor shortages in every technical field. Simultaneously, armor and mechanized forces had expanded exponentially, from a few hundred tanks in 1940 to tens of thousands by 1944. Every tank, every truck, every piece of mechanized equipment required constant maintenance, and there simply weren't enough trained male mechanics to do the work.
The solution was revolutionary: recruit women for technical positions, provide systematic training that didn't require prior mechanical knowledge, develop procedures simple enough that anyone with basic aptitude could master them quickly. It violated every assumption about mechanical work and gender roles, but the alternative was having expensive equipment sit broken while trained male mechanics were too few and too far away. I'd applied because the salary was better than teaching, and because I was curious whether my mathematical mind could adapt to mechanical systems. The aptitude test had been surprisingly straightforward: spatial reasoning, logical problem-solving, following complex instructions, manual dexterity. I'd scored in the top 5%, been accepted immediately, and found myself on a train to the Ordnance Department's Technical Training School at Aberdeen Proving Ground, Maryland. The training had been unlike anything I'd experienced. Instead of theoretical knowledge, we learned practical procedures. Instead of understanding why things worked, we learned how to make them work. Each repair operation was broken into numbered steps, with clear instructions, specific tool requirements, and verification checkpoints. Transmissions, engines, final drives, electrical systems. Every component had been analyzed and documented in manuals that assumed the mechanic knew nothing about mechanical engineering. You don't need to understand thermodynamics to rebuild an engine, our instructor had explained during the first week. You need to follow procedures exactly, verify each step, and know when to ask for help. The Army has spent 3 years developing these manuals specifically so people with no mechanical background can maintain combat equipment. Your job is to trust the system and execute it precisely. The German approach was opposite. Their maintenance personnel were trained craftsmen who'd completed multi-year apprenticeships, who understood mechanical systems holistically, who could diagnose and repair through accumulated expertise. It produced superior individual mechanics, but required years of training, and couldn't scale rapidly when equipment numbers exploded. American approach was systematic. Train adequate mechanics quickly using documented procedures, verify their work through systematic inspection, and achieve good enough results fast enough to meet operational demands. It wasn't elegant, but it worked at industrial scale. After 8 weeks of training, I'd been shipped to England as part of the Ordnance Department's Civilian Technical Specialist program. By D-Day plus 30, I was in France. By September, I was in Belgium. And by December, I was one of approximately 4,500 women working in forward maintenance depots across Europe, keeping American armor operational despite conditions that were destroying German maintenance capabilities. The transmission rebuild proceeded according to the manual's systematic sequence. Input shaft assembly, components 1 through 47 installed in numerical order, each torque specification verified, and each bearing race checked for proper seating. Intermediate shaft assembly, components 48 through 93, synchronized gear engagement verified at each stage. Output shaft assembly, components 94 through 156, final tolerances measured with precision gauges. At 8:47 hours, I had the main transmission assembly complete and was installing it back into the tank's hull, a process that required an overhead hoist to position the 800-pound unit correctly and 4 hours of connection work to mate it with the engine, final drives, and control linkages. "Morrison, you've got admirers." Wheeler appeared again, this time with 2 other women I recognized from adjacent work base, Sarah Chen, former seamstress from San Francisco, now a track and suspension specialist, and Margaret O'Brien, former telephone operator from Boston, now an electrical systems expert. "Lieutenant Patterson is telling everyone about the miracle mechanic who's rebuilding his transmission in 4 hours," Chen said, grinning. "Half the infantry officers in the depot are placing bets on whether you'll actually finish on time." "I'll finish at 10:27 hours, I replied, checking my watch and mentally calculating remaining tasks. 3 minutes ahead of schedule. "The Germans wouldn't believe this if they saw it," O'Brien observed, watching me align the transmission with its mounting points. "Women maintaining tanks, systematic procedures instead of mechanical expertise, repairs measured in hours instead of days. Everything about this violates their assumptions about how maintenance works."
She was right. German doctrine assumed maintenance was a rear echelon function, performed by specialized personnel at established facilities. Damaged tanks were transported to depot-level repair facilities, often hundreds of miles behind the lines, where factory-trained mechanics would perform comprehensive rebuilds over days or weeks. American doctrine brought maintenance forward. We had mobile maintenance units that operated just behind the front lines, civilian specialists like me working in forward depots, and systematic procedures that enabled rapid repairs close to combat zones. A tank damaged today could be back in action tomorrow, not 3 weeks later after a journey to rear area workshops. The strategic impact was enormous. German Panzer divisions were declining in combat effectiveness, not primarily through battle losses, but through maintenance failures. Their tanks were mechanically superior, but maintenance intensive. The Tiger tank required 150 hours of maintenance for every 10 hours of operation. The Panther's final drive failed so frequently that replacement was considered routine. Even the reliable Mark IV required extensive maintenance that German logistics couldn't provide under combat conditions. Meanwhile, American Shermans were simpler, more reliable, and supported by maintenance infrastructure that kept them running despite heavy use. The Sherman required 30 hours of maintenance per 10 hours of operation, 1/5 the Tiger's requirement. When something did break, systematic procedures and forward-deployed specialists like me could perform repairs in hours rather than days. By December 1944, the average German Panzer division had perhaps 30% of its authorized tanks operational at any given time. American armored divisions maintained 85 to 90% operational rates. That difference, the ability to keep armor running, mattered more than any technical advantage German tanks possessed. At 0954 a.m., I finished connecting the final control linkages and began the systematic testing sequence. Engine start, normal. Transmission engagement, smooth across all gears. Track drive, power transmitted correctly to both final drives. Control response, steering and braking functioned per specifications. Morrison, Lieutenant Patterson is back. Wants to know if his tank is ready early. I checked my watch, 10:02 hours. 28 minutes ahead of schedule. Tell him it's ready now. Full systems test complete, all parameters within normal range. This tank is combat ready. Patterson appeared moments later with 3 other infantry officers, all looking at me with expressions mixing skepticism and hope. "Ma'am, you're sure?" The maintenance battalion said. The maintenance battalion uses traditional methods that work well in established facilities with unlimited time. We use rapid repair procedures developed specifically for forward deployment. This transmission has been rebuilt according to technical manual specifications. I personally verified every component. The systems test confirms all parameters are nominal. This tank will perform exactly as designed. One of the other officers, a captain whose name tape read Williams, spoke up. "With respect, miss, how can you be certain? That's a complex repair." "Because I've performed this exact repair 43 times in the past 6 months. Because every step is documented in technical manuals that specify exact procedures. Because systematic verification at each stage ensures correctness. Because this approach has been developed over 3 years specifically to enable rapid, reliable maintenance by personnel without traditional mechanical training." I gestured to the tank, now idling smoothly with its rebuilt transmission. "Captain, that Sherman's transmission will function correctly until it accumulates another 1,500 miles or 300 combat hours, whichever comes first. At that point, it will require routine maintenance according to the schedule in your technical manual. The rebuild I just completed meets every Army specification for depot-level transmission overhaul. I guarantee it personally." Patterson climbed into the commander's position, signaled his driver, and put the Sherman through its paces. Forward, reverse, pivot turns, gear changes. When he climbed back down, his face showed the relief of a man who just received an unexpected gift. "It's perfect," he said quietly. "Shifts smoother than when we first got this tank 6 months ago. I don't know how you did this in 4 hours, but thank you. This tank is going to save lives." "Just doing my job, Lieutenant. Keep it maintained according to schedule, and it'll bring you home safely." As the Sherman rolled out of the depot toward the front lines, Wheeler appeared at my shoulder. "That's number 44. You're averaging 1 major repair every 3 days. At this rate, you'll rebuild 300 transmissions before the war ends." "Someone has to keep the tanks running," I replied, already walking toward Bay 11 where another Sherman waited with engine problems. "The Germans think their mechanical superiority matters. We're proving that maintenance capability matters more." The scope of women's contribution to military maintenance operations in World War II remains largely unknown outside technical military history. By 1945, approximately 750,000 American women were working in maintenance, repair, and logistics roles supporting U.S. military operations worldwide. They weren't auxiliary personnel performing clerical work. They were mechanics, electricians, technical specialists performing complex repairs on combat equipment. In the Ordnance Department alone, over 50,000 women worked as civilian technical specialists in maintenance depots across Europe and the Pacific. They rebuilt engines, repaired transmissions, overhauled drives, rewired electrical systems, performed welding repairs, rebuilt weapons systems, and maintained every type of mechanized equipment the military deployed. The Women's Army Corps included another 150,000 women performing technical roles, many in direct support of armored and mechanized units. WWII mechanics maintained vehicles, WWII ordnance specialists repaired weapons, WWII communications technicians maintained radios and field telephones. In Great Britain, the Auxiliary Territorial Service employed over 200,000 women, many in technical roles supporting British and American forces. In the Soviet Union, women comprised up to 30% of maintenance personnel in some units, performing repairs under combat conditions. The German military, by contrast, never systematically employed women in technical maintenance roles. Nazi ideology held that women were unsuited for mechanical work, that technical roles should be reserved for men, that military effectiveness required traditional gender divisions. This ideological rigidity contributed to German maintenance failures. They simply didn't have enough trained mechanics to maintain their increasingly complex equipment. The mathematical impact was devastating for Germany. Each American armored division had approximately 250 tanks. Maintaining 85% operational availability meant 212 to 213 tanks ready for combat. Each German Panzer division had approximately 180 tanks authorized. Maintaining 30% availability meant 54 tanks operational. An American division with technically inferior tanks but superior maintenance could deploy 4 times the operational armor of a German division with superior tanks but inadequate maintenance.
Multiply this across all armored formations, and the strategic effect became overwhelming. German Panzer forces declined not primarily through combat losses, but through maintenance failures they lacked personnel to correct. American armor expanded continuously because maintenance infrastructure kept pace with equipment deployment. And a significant portion of that maintenance infrastructure consisted of women the Germans would have considered incapable of mechanical work. December 20th, 1944. 1840 hours. The ordnance depot was operating around the clock now, every bay occupied, mechanics working 18-hour shifts to keep armor flowing back to units fighting desperate defensive battles. The Battle of the Bulge had reached its crisis point. German forces had penetrated 50 miles into American positions, threatened to capture critical supply depots, aimed to split Allied armies and recapture Antwerp. Every functioning tank mattered. Every hour of downtime meant American infantry facing German armor without support. The mathematics were brutal and simple. We had to repair tanks faster than combat was destroying them, or the front would collapse. I was on my 3rd consecutive shift, having completed 2 transmission rebuilds, 1 final drive replacement, and an engine overhaul in the past 16 hours. My hands ached, my back protested every movement, and I'd consumed enough coffee to wire a small city. But Bay 7 held another Sherman with track damage, and the work wouldn't wait for convenient rest schedules. "Morrison," Wheeler's voice was urgent. "We've got a situation. That Sherman you repaired for Lieutenant Patterson, it took a direct hit from an 88mm round 3 hours ago. Penetrated the hull, killed the driver and bow gunner. But the tank drove itself back to friendly lines on the transmission you rebuilt. Patterson and the rest of his crew survived because the tank remained mobile after taking lethal damage." I stopped working, letting the impact of that information settle. 2 men dead, but 3 alive because a transmission I'd rebuilt kept functioning after catastrophic damage. The mathematics of war reduced to mechanical reliability and rapid repair. "Patterson wanted you to know," Wheeler continued. "Said your work saved his life. Wanted to thank you personally, but they've already sent him back to the line in a replacement tank." "I'm glad he survived," I said quietly. "And tell him to keep that new tank maintained properly." That was the nature of our work. We rarely saw the direct impact of repairs performed in fluorescent-lit bays behind the lines. We rebuilt transmissions, repaired engines, fixed electrical systems, and sent tanks back to combat without knowing whether they'd save lives or become metal coffins. We worked on faith that proper maintenance mattered, that systematic procedures produced reliable results, that keeping equipment running was as important as fighting battles. The German mechanics who maintained their technically superior Panzers were working under impossible conditions by December 1944. Their supply chains had collapsed, spare parts were unavailable, maintenance facilities were being overrun, and trained personnel were being conscripted as infantry to fill gaps in defensive lines. Their sophisticated tanks were sitting broken because nobody had the parts, tools, or time to fix them. Meanwhile, American logistics was functioning at industrial scale. Spare parts arrived by the truckload. Maintenance procedures were documented in clear technical manuals. Personnel like me could perform complex repairs quickly because systematic methods eliminated the need for traditional expertise. The Sherman might be technically inferior, but it was being maintained at rates German equipment couldn't match. The psychology of systematic maintenance versus traditional craftsmanship emerged clearly when comparing American and German approaches to the same problems. A captured German tank manual we had studied included this guidance on transmission repair. Transmission overhaul requires factory-trained specialist with minimum 3 years mechanical experience. Field repair is not recommended. Transport vehicle to depot-level maintenance facility for proper rebuild by qualified personnel. The American technical manual for the same operation stated, transmission removal and installation, time required 4 to 6 hours, personnel required 1 mechanic plus 1 assistant, special tools required per list page 7-3. Follow procedures steps 1 through 47 in sequence. Verify each step before proceeding. The German approach assumed expertise, experience, and ideal conditions. The American approach assumed minimal knowledge, provided systematic instructions, and enabled repairs under field conditions. One approach produced perfect repairs slowly when conditions allowed. The other produced adequate repairs quickly under any conditions. By late 1944, adequate repairs quickly was winning the war. German tanks sitting in depot facilities awaiting expert attention were irrelevant to battlefield outcomes. American tanks being repaired in forward positions and returned to combat within hours were decisive. The women performing those repairs weren't mechanical geniuses or natural-born craftsmen. We were systematic workers following documented procedures, trained quickly to perform specific tasks, achieving results through organization rather than expertise. The Germans would have dismissed us as inadequately qualified amateurs. We proved that systematic organization mattered more than individual expertise when operations scaled to industrial levels. Christmas Day, 1945. The Ordnance Depot received special rations: turkey, cranberry sauce, fruitcake, real coffee instead of the powdered substitute we'd been drinking for weeks. We took a 4-hour break, the first extended rest since the Bulge offensive had begun, and gathered in the depot's makeshift mess hall to celebrate the holiday. Sarah Chen raised a mug of coffee and toast. To women mechanics, who the Germans think don't exist, but who keep this army moving. To systematic procedures, which work better than traditional expertise when you need repairs fast. To the Shermans we maintain, which might not be the best tanks, but they're the tanks that actually run when needed. We drank our coffee and returned to work. The battle was still raging, tanks were still breaking, and repairs wouldn't wait for convenient scheduling around holidays. This was industrial warfare at its peak. Continuous operations, systematic processes, personnel performing specialized tasks around the clock to maintain equipment that kept armies moving. The German army was celebrating Christmas in frozen foxholes, their armor stalled for lack of fuel and maintenance, their offensive grinding to a halt not through enemy firepower, but through logistical collapse. Their technically superior Panzers were becoming steel pillboxes as mechanical failures accumulated faster than repairs could be performed. Meanwhile, American armor was being maintained by women the Germans thought incapable of mechanical work, using procedures the Germans considered inadequate, achieving operational rates the Germans couldn't match. By early January 1945, the Battle of the Bulge had turned irrevocably against Germany. Their offensive had failed through multiple causes: fuel shortages, air superiority, tactical defeats, but maintenance failures contributed significantly. German armor that began the offensive with approximately 650 operational tanks ended with fewer than 150 still running. Not destroyed in combat, simply broken down and irreparable under field conditions. American armor began the defensive phase with approximately 800 operational tanks and ended the counteroffensive phase with over 1,200. Despite combat losses, we'd actually increased operational strength through efficient maintenance and rapid deployment of repaired vehicles from forward depots. A captured German tank officer, interrogated after the battle, provided revealing testimony. We were told American maintenance was inadequate, their equipment unreliable, their support personnel untrained. This was completely wrong. American tanks that we damaged would reappear in combat within days. Our own damaged tanks sat waiting weeks for repair. By the offensive's end, we were destroying more of our own tanks through abandonment than the Americans were destroying through combat. Their maintenance superiority was as decisive as their air power. That assessment captured the truth that German high command had never understood. In industrial warfare, maintenance capability mattered as much as combat capability. The side that could keep equipment running would defeat the side with better equipment that sat broken. And American maintenance capability depended significantly on personnel, women performing technical work that German ideology said couldn't exist and German doctrine had never prepared to counter. April 30th, 1945. The Ordnance Depot at Liege received word that Berlin had fallen. The war in Europe would be over in days. Around me, mechanics were celebrating, hugging each other, crying with relief that they'd survived. I stood in Bay 7, looking at a
Transmission I'd been rebuilding when the news arrived and felt a complex mixture of emotions.
pride in what we'd accomplished. In 9 months, I'd personally repaired or rebuilt components on over 300 tanks, keeping American armor operational through some of the fiercest fighting of the European campaign. Women like me, working in depots across Europe, had maintained thousands of vehicles, performing millions of maintenance operations, keeping Allied armies mobile while German forces gradually lost the ability to maneuver. Satisfaction that our approach had worked. The systematic maintenance procedures we'd followed, which Germans dismissed as inadequate, had proven more effective than traditional craftsmanship when operations scaled to industrial warfare. We'd achieved higher operational rates with less training, faster repairs with simpler procedures, better results through organization than Germans achieved through expertise. Sorrow for the cost. Every tank I'd repaired had gone back to combat, where men died in it or because of it. The transmission I'd rebuilt for Lieutenant Patterson had kept his tank mobile after catastrophic damage, saving his life but possibly contributing to enemy deaths. There was no clean moral mathematics in warfare, no way to balance lives saved against lives taken. But overwhelming all other feelings was simple relief. The war was over. The killing would stop. I could go home to Nebraska, muster out of civilian specialist service, awarded a certificate of appreciation and a recommendation letter from the Ordnance Department. The certificate mentioned my contributions to maintenance operations. It didn't mention the 317 separate repair operations I'd performed, the thousands of hours worked, and the tanks that survived because transmissions I'd rebuilt kept them mobile. Teaching high school mathematics in Lincoln, Nebraska felt surreal after 9 months of industrial warfare. My students complained about quadratic equations, while I remembered calculating gear ratios for transmission repairs. They struggled with word problems, while I had solved real problems where wrong answers meant soldiers died. But gradually, I readjusted to peace, resumed normal life, became again what I'd been before the war, a teacher in mathematics in a small Nebraska city. The skills I'd learned maintaining tanks became irrelevant in peacetime. The systematic procedures I'd mastered were filed away in technical manuals nobody would read again. But those procedures and that experience had changed me permanently. I'd learned that complex technical work could be systematized and taught to anyone with basic aptitude. I'd proven that women could perform mechanical repairs as competently as men when given proper training and opportunity. I'd demonstrated that organization and systematic methods mattered more than traditional expertise when operations scaled to industrial levels. Most importantly, I'd helped win a war by keeping tanks running, proving through practical results that American approaches to maintenance, systematic, scalable, efficient, were superior to German traditional craftsmanship when warfare reached industrial scale. In 1985, 40 years after the war ended, the Society of Automotive Engineers held a symposium on World War II maintenance operations. They invited veterans of maintenance units to speak about their experiences. I was one of 12 women who attended from a maintenance workforce that had numbered 750,000 at its peak. We stood together on stage while a moderator read statistics about our contributions. Millions of maintenance operations performed, thousands of vehicles kept operational rates that exceeded enemy capabilities by factors of 2 or 3. The audience of mostly male engineers and mechanics applauded politely, but I could see skepticism in some faces. Could these elderly women really have performed the mechanical work we claimed?
Then the moderator showed film footage from 1944, women rebuilding engines in forward depots, performing track repairs in muddy fields, conducting electrical system overhauls in portable workshops. The footage showed us working systematically, following documented procedures, achieving results that spoke for themselves in operational equipment rolling out of maintenance bays. The applause that followed wasn't polite, it was genuine recognition of capability demonstrated through results. These engineers understood that the systematic approach we'd used was revolutionary, that breaking complex repairs into teachable procedures enabled rapid training, that our methods had become standard practice in modern maintenance operations. "You changed how the world thinks about maintenance," one engineer told me afterward. "The procedures you followed in 1944, systematic documentation, step-by-step verification, enabling rapid training, that's how every modern maintenance organization works. You proved the concept under combat conditions." He was right. Modern maintenance across every industry, aviation, automotive, industrial equipment, commercial vehicles, uses systematic procedures derived from methods developed during World War II. The approach that enabled mathematics teachers to rebuild tank transmissions became the foundation for how complex equipment is maintained worldwide. The German tank crews who'd laughed at American amateur mechanics learned through systematic defeat that their assumptions were wrong. Every engagement where German tanks sat immobilized while Shermans kept running taught them that maintenance capability mattered more than mechanical superiority. Every battle where American armor maintained operational rates far above German capabilities demonstrated that systematic American methods defeated traditional German craftsmanship. By war end, captured German tank officers universally acknowledged American maintenance superiority. One Panther commander stated during interrogation, "We had better tanks, you had better maintenance. In the end, the tanks that run decide battles, not the tanks with superior specifications. You kept your inferior tanks running better than we kept our superior tanks. That decided the ground war in Europe." That assessment was accurate, but incomplete. American tanks weren't just kept running by better logistics, they were kept running by personnel German ideology said couldn't do technical work, using procedures German doctrine considered inadequate, achieving results German high command thought impossible. 750,000 women performing maintenance and repair operations constituted a strategic advantage Germany never countered because Nazi ideology prevented them from employing women in technical roles. Every woman maintaining vehicles, rebuilding transmissions, repairing engines, overhauling equipment was proving through practical work that gender had nothing to do with mechanical capability. We didn't do it for social progress or gender equality. We did it because armies needed maintenance and women were available to perform it. But in proving we could do the work as well as men, in demonstrating that systematic procedures mattered more than traditional training. In achieving results that helped win the war, we changed forever how industrial societies think about gender and technical work. I'm 97 years old now, the last surviving member of my Ordnance Depot team. Sarah Chen died in 2003, Margaret O'Brien in 2011. Of the approximately 50 women who worked in our facility during 1944-1945, I'm the only one left to tell the story. Young women sometimes ask me what it was like, whether we felt we were pioneers, whether we understood we were changing social assumptions about women and technical work. The truth is simpler than they expect. We were doing jobs that needed doing, solving problems that needed solving, keeping equipment running because armies depended on it. We didn't think about historical significance or social progress. We thought about the transmission that needed rebuilding, the engine that wouldn't start, the electrical system that had failed. We followed systematic procedures, verified our work, and sent repaired equipment back to units that needed it. The revolution happened because we did our jobs competently, proving through results that women could perform technical work as well as men. The German tank crews who mocked American amateur mechanics learned their mistake through systematic mechanical failure. Their technically superior Panzers sat broken while our technically adequate Shermans kept running. Their master craftsmen couldn't maintain equipment fast enough. Our systematic workers maintained equipment at industrial scale. Their traditional expertise was inadequate for industrial warfare. Our systematic procedures were perfect for it. In the end, warfare at industrial scale wasn't won by traditional expertise or individual excellence. It was won by systematic organization, documented procedures, rapid training, and proper utilization of all available human resources regardless of gender. The side that understood this, that embraced systematic methods and utilized its entire population's capabilities, would always defeat the side that clung to traditional assumptions about how work should be organized and who could perform it. The German army discovered this through defeat. The 750,000 women maintaining Allied military equipment proved it through victory. And the lesson remains valid today. Proper organization and systematic methods applied at scale with full utilization of available talent will always defeat traditional approaches that rely on limited numbers of highly trained specialists. We rebuilt 317 transmissions in 9 months and helped win a war, not because we were mechanical geniuses, but because American industrial organization had figured out how to break complex work into simple procedures that anyone could master quickly. That was the revolution. Not that women could do mechanical work, but that systematic organization made complex mechanical work accessible to anyone with basic aptitude and proper training. The Germans laughed at our amateur mechanics. We responded by keeping every Sherman running while their Panzer sat broken. That was victory, speaking louder than any argument about expertise or tradition or gender roles. The tanks that run decide battles. We made sure our tanks ran. They didn't. We won, they lost. The mathematics was that simple.